Okay, so what if I told you your brain is lying to you, like every single day,
Hmm. That's an interesting thought.
right? That you're not really thinking, you're just guessing.
Guessing, really.
Yeah, that's what we're gonna dive into in this first deep dive.
Wow, okay. I'm intrigued.
Yeah, we're uncovering why even like the smartest people, like geniuses,
Mm-hmm.
make dumb mistakes, and more importantly, like how to outsmart our own minds.
Right. So we're going to learn to think better.
Exactly. You'll never trust your gut the same way again.
I'm ready to have my mind blown.
You're here because you want to get smart, right? Fast.
Definitely.
And that's what we're all about. We're like cutting through all the noise, and we're bringing you the most important insights into how we think. And trust me, some of this is going to be really surprising.
I'm excited to hear it.
Yeah,
So we think we're in control, but a lot is happening behind the scenes in our minds.
right, right. Okay, so one of the like really basic things to grasp here is that we kind of operate with two different speeds of thinking.
Two speeds.
Yeah. Imagine like, you've got this super fast intuitive system.
Okay.
Let's just call it system 1.
System one.
Okay. And then you've got this like slower, more deliberate one,
Right.
system 2.
So two systems, two speeds. Got it.
Yeah, exactly. So system 1, this is running all the time in the background.
Right.
This is what lets you, like recognize a face immediately,
Right.
or that a stove is hot without actually touching it,
Oh, yeah.
or maybe feel uneasy like in a certain situation.
Those gut feelings.
Yeah, exactly. It's quick, it's automatic, it's mostly unconscious.
So it's happening without us really realizing it.
Yeah.
Interesting.
Think about like driving down a familiar road. You're not, actively thinking about every single turn, when to hit the brakes.
Right.
That's mostly system 1. See red light, stop.
Yeah, it's automatic.
Your loud noise, flinch. It's these instant reactions, it's like it's these gut feelings that just happen.
They just appear.
Yeah.
So what you're saying is system one is always working in the background, making these snap judgments.
Exactly. Like you see a lamp on a desk, boom, it's there. Someone sounds a little off on the phone, you pick up on it. These things they just happen.
Fascinating. We don't even realize how much our brain is doing for us.
Right. And most of the time, this intuition is super helpful. It helps us just get through the world.
Makes sense. Efficiency is key.
Right. But here's the really interesting part. We often have this really strong sense of conviction, in these gut feelings, even when they're totally wrong.
Really? Even when we're wrong?
Yeah. And sometimes it's like so obvious to someone else that we messed up.
Oh, I can definitely relate to that.
Right. So what we want to do today is like get a better understanding of these common mistakes in thinking.
Okay. Yeah. Identify those pitfalls.
Yeah. So by understanding how our intuition can mislead us, right, we can hopefully become more aware of our own biases. Maybe even catch ourselves before we make a not so great decision.
It's like learning the warning signs for our own thinking.
Exactly.
So how did this research into intuitive errors actually begin? Where did it all start?
Well, it all kind of kicked off with this one moment back in the late 1960s. Picture this, okay? A researcher is giving a seminar,
Okay.
presenting some work, trying to answer this seemingly simple question about how well people just intuitively understand basic statistics.
Statistics.
Yeah. Like, are we naturally good at statistical reasoning? The same way we seem to have this knack for language.
Right?
Think about it. How do kids learn these crazy grammar rules without anyone really explicitly teaching them?
Yeah. It's pretty amazing.
So the researchers, they wondered, right, if we have a similar like built-in intuition for things like probability and sample size, like do we just get it?
So they were looking for a statistical instinct, like a language instinct.
Yeah. And the answer, after a lot of debate, was kind of like, not really.
Not really.
Not really.
So our brains aren't natural statisticians.
Not as much as we might think. And this led to this really significant collaboration between two researchers.
Okay.
And they started to realize that even their own statistical intuitions, weren't always on point,
Even though they were experts.
even though they were the experts.
Yeah, right.
They noticed that they were like too quick to trust findings from studies with small samples. Not enough data.
Ah, so the size of the study mattered.
Yeah, it did. And what's really, really interesting is they realized this wasn't just them.
Oh, okay.
They decided to see if other experts, people who should know better, right, fellow researchers, even authors of statistics textbooks.
Wow, they went to the source.
They went straight to the source
Yeah.
to see if they were also susceptible to these intuitive errors.
Interesting. So how did they test this?
Well, they designed these surveys with, realistic research scenarios, the kind of stuff they dealt with all the time, where you had to make statistical judgments,
Okay, real world scenario.
real world stuff. And they took these surveys to a meeting of experts.
Like a conference or something.
Yeah, like a conference of experts in mathematical psychology,
Yeah.
the big brains.
Okay, so these were the people who should be really good at this.
Exactly. And the results were pretty surprising. Even these seasoned researchers, they consistently overestimated the likelihood of getting similar results if they repeated an experiment, but with a small group of people,
So they didn't understand the importance of sample size.
not intuitively.
Wow.
And they gave surprisingly bad advice to a hypothetical student about, how much data they needed for their research to be meaningful.
So even the experts were falling prey to these intuitive traps.
Yeah, even the experts.
That's pretty humbling, actually.
It is. It really shows that, we're all susceptible to these mental shortcuts, these heuristics that our brains use to simplify complex questions and make quick decisions.
Heuristics, what are those?
Think of them like rules of thumb, you know?
Okay.
They're often helpful, they make things efficient, but they can lead us to some predictable errors in thinking.
So like taking a shortcut that sometimes leads you astray.
Exactly.
All right, so what are some of these heuristics? Can you give me an example?
Yeah, absolutely. One of the most well-known ones is the representativeness heuristic.
Okay, representativeness heuristic.
It's all about how much something seems to fit a certain category or a stereotype.
Okay, so like judging a book by its cover.
Kind of.
All right.
Imagine you're introduced to someone named Steve,
Steve, okay.
and you're told that Steve is really shy, very withdrawn, always helpful, but not really interested in people or the real world. He's seen as meek and tidy, has a need for order, structure, and he's passionate about details.
Steve sounds like an interesting character.
Right. So based on this description, is Steve more likely to be a librarian or a farmer?
Oh, a librarian for sure. I mean, he fits the stereotype perfectly, right? Shy, organized, loves details.
See? That's exactly what most people think. It just feels like a perfect match. But this is where this representativeness heuristic can really trip us up.
Trip us up. How so?
Well, think about it. How many farmers are there compared to librarians?
I'm not sure. Probably more farmers.
A lot more.
Okay.
In most Western countries, there are just way more people working in agriculture than in libraries.
Yeah.
So even if he fits the librarian stereotype perfectly, statistically speaking, it's far more likely that someone with those personality traits would just end up in a profession with a larger population.
Oh, right, because there are more farmers to begin with. So even if a small percentage of farmers fit that description, it's still more than the number of librarians who do.
Exactly. We forget about this basic statistical fact. We call it the base rate.
Base rate.
And instead, we rely almost entirely on how similar Steve's description is to our image of a librarian.
So we focus on the stereotype and ignore the bigger picture.
Yeah, we prioritize the story over the numbers.
Got it. So the representativeness heuristic can make us jump to conclusions based on stereotypes without considering the actual probabilities.
Exactly. And that can lead to some really, really big misunderstandings.
Okay, so that's one heuristic. What about another one?
Another really common mental shortcut is the availability heuristic.
Availability heuristic.
Okay. This is where we estimate the likelihood of something happening based on how easily examples come to mind.
So if it's easy to think of examples, we assume it's more common.
Right. And this can be super deceptive because what's easy to recall isn't always what's actually most common.
Makes sense. Our memories can be biased.
Okay, try this. In the English language, is the letter K more likely to appear as the first letter of a word or the third letter?
K. Well, like kangaroo, kitchen, king, those all come to mind easily, so I'd say it's more common as the first letter.
Most people say that because those examples, they pop into our heads so quickly, we assume K must be more frequent as the first letter.
It feels like it should be true.
Right. But here's the thing. If you actually analyze a large body of English text, you find that letters like K, L, N, R, V, they actually appear more frequently in the third position of words.
No way. So I was wrong.
Yeah. Our reliance on how quickly we can retrieve examples, That's the availability heuristic.
Got it.
It leads us to an incorrect judgment about the actual frequency. What's easy to remember isn't always representative of reality.
Okay, I'm starting to see how tricky these heuristics can be. Do you have another example of the availability heuristic?
Yeah. Have you ever noticed how you might get the impression that a certain type of event is more common than it really is, just because you hear about it a lot?
Yeah, that definitely happens. Like when you see a lot of news stories about a certain type of crime, it starts to feel like it's happening everywhere.
Exactly. Let's say you start to feel like a certain kind of scandal is rampant among a particular group. Maybe you just seen a bunch of news reports about it, right?
Yeah.
The problem is those events might be getting a lot of media attention precisely because they're unusual. They're noteworthy.
Mm.
So the constant exposure makes them highly available in your memory, leading you to overestimate how often they actually occur.
It's like our perception is skewed by the news cycle.
Yeah, it's the vividness and the frequency of media coverage that distorts our sense of reality.
So we need to be careful about how we interpret the information we're exposed to.
Definitely.
Okay, so we've talked about representativeness and availability. Are there any other heuristics we should be aware of?
Oh yeah, tons. But let's talk about a really subtle but powerful influence on our thinking.
Okay, lay it on me.
Anchoring.
And
Yeah, anchoring. It's where an initial piece of information, even if it's totally random, irrelevant, can significantly affect our judgments and estimates.
so like the first thing we hear influences us.
Yeah. Imagine you're trying to guess how much a new smartphone will cost.
Okay, a new smartphone.
And before you've even had a chance to really think about it, someone throws out a random number, say $1,000. Yeah,
$1,000.
even if you know that number is just pulled out of thin air, it can act as an anchor, like it pulls your own estimate upwards. You might end up guessing like $800 or $900.
So just hearing that number makes me think it's worth more.
Yeah. Whereas if the initial anchor had been like $200, your final guess might be way lower.
Wow, that's crazy. So even a random number can influence us.
Yeah. And what's really wild is that this anchoring effect happens even when we know that the initial anchor is meaningless.
You're kidding. Even when we know it's wrong.
Yeah. There was this classic experiment. People were asked to estimate the percentage of African nations that are members of the UN. But before they made their estimate, they were asked this seemingly unrelated question.
Oh.
Is the percentage higher or lower than 10% for one group?
Okay.
And is the percentage higher or lower than 65% for another group?
So they were given different starting points.
Exactly. And the results, the group that was initially asked about the 10% anchor, they gave significantly lower final estimates than the group anchored by the 65% figure.
No way. So just hearing those numbers influenced their guesses, even though they knew it was random.
Yeah. That completely arbitrary starting point, that number, just being exposed to it briefly had a powerful influence on their final answer.
It's like our brains latch onto that first piece of information, even if it makes no sense.
Yeah, and adjust from there.
Anchoring is pretty sneaky.
It is. It's everywhere.
All right, so we've got representativeness, availability, and anchoring. What other mind-bending tricks does our brain have up its sleeve?
Okay, are you ready for a real head scratcher?
Hit me with it.
Priming.
Priming. Okay, what's that?
This is about how subtle cues in our environment, often unconscious cues, can influence our thoughts, feelings, even our behaviors.
So like subliminal messaging.
Kind of.
Okay.
It's like our brains are constantly being nudged in certain directions without us even realizing it.
That sounds a little creepy, actually.
It can be.
So can you give me an example of this priming thing?
Yeah. There's this famous experiment called the Florida effect.
Florida effect.
Yeah. Okay, so researchers, they subtly exposed a group of students to words associated with old age.
Old age.
Yeah, like Florida, gray, wrinkled, slow, forgetful.
Okay, stereotypical old people words.
Right, exactly. And they didn't explicitly say anything to the students about age.
Okay, so it was subtle.
Very subtle.
And then what happened?
Well, after this word exposure, they observed how quickly the students walked down a hallway.
Just walking.
Yeah, as they were leaving. And get this, the students who were exposed to those old age words, they walked significantly slower than the other students who hadn't seen those words.
Wow, so just thinking about those words made them walk slower.
Yeah. And here's the kicker. The students were completely unaware that they'd been influenced.
But they had no idea.
No idea. They weren't consciously thinking about being old or walking slowly. Their behavior was just, it was subtly altered by the priming.
That's
It
incredible.
is. It's like your brain picks up on these subtle cues and just starts to act in line with them without you even knowing why.
That's wild. So it's not just about walking, right? This priming can affect other things too.
Oh, absolutely. There have been tons of experiments showing how even just subtle reminders of money can affect our behavior.
Money.
Yeah, like in these money priming studies,
Mhm.
simply being exposed to images of coins or seeing words related to finances or even just being in a room where money is subtly present can make people behave more independently and less willing to ask for help.
So it's like money puts us in a different mindset.
Exactly. It's like the concept of money activates this mindset of self-reliance. Like, I can handle this on my own.
Interesting. So it's not just the money itself, it's the idea of money.
Yeah, it's the idea, the concept.
Fascinating.
And it gets even more specific than that.
Okay, how so?
In experiments looking at cooperation, researchers found that people who are primed with words related to business or competition, they tend to be less generous in tasks where they had to share resources with others.
Oh, so like the priming makes them more competitive.
Yeah.
Interesting.
It's like it activates this competitive frame of mind that then influences their social behavior.
So the words we're exposed to can actually affect how we interact with others.
Yeah, even subconsciously.
That's amazing.
And there's another example I think you'll find really cool. Think about the simple act of being watched.
Being watched.
Yeah. Even a symbolic reminder of being observed can change our behavior. There were these studies involving honesty boxes where people are, they're on the honor system to pay for like drinks or snacks.
Oh, right.
Researchers found that simply placing pictures of human eyes near the box, like even just simple cartoon eyes, led to a huge increase in the amount of money people contributed.
So it's like they felt like they were being watched, even though it was just a picture.
Yeah, compared to when there were pictures of like neutral objects like flowers or something.
Wow. So even a subtle cue like that can make us more honest.
Exactly. It's like that subtle visual cue triggers this feeling of being monitored, even if no one's actually watching.
That's pretty powerful.
Yeah, it is. And all these priming effects, they really highlight how much our thoughts and actions are shaped by things that are happening outside of our conscious awareness. It challenges this idea we have that, we're totally rational and in control.
Right. It's like our conscious mind is just the tip of the iceberg.
Exactly. There's so much happening beneath the surface.
So we need to be more aware of these unconscious influences.
Definitely.
This brings us to another interesting concept, right? Cognitive ease and cognitive strain. What are those exactly?
Yeah, so these are basically, it's how easy or difficult it is for our brains to process information.
Makes sense. Some things are harder to think about than others.
Right. Think about like reading a sentence in a clear, simple font,
Yeah.
versus like trying to decipher something written in messy handwriting.
Oh, yeah, that's definitely more work.
The clear font, it's effortless, right?
Uh-huh.
That's cognitive ease. The messy handwriting, that requires more mental energy. That's cognitive strain.
So ease is good, strain is bad.
Well, not
Yeah.
necessarily bad, but these feelings can have a surprising impact on our judgments.
Really? How so?
So when we experience cognitive ease, when things feel familiar, fluent, coherent,
Mhm.
we're more likely to rely on system one, that
Hmm.
intuitive thinking.
We just go with our gut.
Yeah, we might just accept information without really, really examining it. But when we're in a state of cognitive strain, when things feel unfamiliar, complex, difficult, it tends to activate system two.
The slower, more deliberate system.
Exactly. We become more analytical.
So cognitive strain makes us think harder.
Yeah.
I'm starting to see how this all connects. Can you give me an example of how this works in practice?
Yeah, absolutely. Let's try a little brain teaser, okay?
Okay, I'm ready.
All right. A bat and a ball cost $1.10 in total. The bat costs $1 more than the ball. How much does the ball cost?
Okay. The bat is $1 more. So the ball must cost 10 cents.
See? That's the answer that pops into most people's heads immediately. It just feels right, right?
Yeah, seems obvious.
But let's actually engage system two for a second and do the math.
Okay, let's see.
If the ball costs 10 cents, then the bat would cost $1.10, right? Because it's $1 more.
Yeah.
That would make the total $1.20.
Oh, right. So that's wrong.
The correct answer is actually the ball cost 5 cents and the bat cost $1.05,
5 cents. Of
Yeah.
course.
which is $1 more than the ball, making the total $1.10.
Okay, I see my mistake. I was too quick to jump to the obvious answer.
Yeah. And what's really fascinating is how many people, even students at top universities, they give that initial incorrect 10-cent answer. It
Yeah.
just shows how easy it is for our lazy system 2 to just accept that first intuitive suggestion from system 1 without really checking.
So we need to be careful about trusting our gut feelings, especially when it comes to numbers.
Exactly. The feeling of ease can be very deceptive.
It's a trap.
It is.
Do you have another example? Maybe one that doesn't involve math.
Yeah, okay, here's one that plays on our intuitive sense of logic.
Okay, I'm listening.
All roses are flowers. Some flowers fade quickly, therefore some roses fade quickly. Does that conclusion logically follow from the first two statements?
Hmm. Well, roses are flowers, and some flowers fade quickly. So yeah, it seems logical that some roses would fade quickly too.
See, it feels right, doesn't it?
It does.
But if you really break down the logic, you'll see that it's possible that the roses are actually among the flowers that don't fade quickly.
Oh, right. It doesn't say that all flowers fade quickly, just some. So the roses could be part of the flowers that don't fade quickly.
Exactly. The first two statements don't necessarily lead to that conclusion about roses. It's just that our belief in a particular outcome can sometimes override our logical reasoning.
So we're more likely to accept things that confirm our existing beliefs, even if the logic isn't sound.
Yeah. System 1 jumps to a conclusion that feels good, feels right, and System 2 doesn't always step in to check.
It's like our brain is trying to make things easier for us, even if it means bending the rules a little.
Right. And this can happen even with things we think we're being logical about.
It's like our brains are masters of self-deception. Okay, so we need to be aware of these logical fallacies too. Are there any other ways that our intuition can lead us astray?
Oh yeah, there's tons. But let's go back to the idea of availability influencing our judgments.
Yeah.
I'm going to ask you a question about frequency.
All right, shoot.
How many murders occur in the state of Michigan in a typical year?
Michigan. Murders. Hmm. Well, Detroit is in Michigan, and Detroit has a pretty high crime rate. So I'd guess that the murder rate in Michigan is probably above average.
See? That's exactly how availability bias can work.
Oh, so.
Well, Michigan is home to Detroit, which, unfortunately has a reputation for having a higher crime rate than many other cities.
Yeah,
So the idea of Detroit and crime, it's very readily available in our minds.
makes sense.
And that vivid, easily recalled information, it can lead us to overestimate the overall number of murders in the entire state.
Even if other parts of Michigan are safer.
Exactly. It's the availability of that specific, maybe more dramatic example that skews our judgment.
Okay, so we need to be careful about letting those vivid examples cloud our judgment.
Definitely. And here's a classic example that plays on context and our tendency to just overlook detail.
Okay, I like a good brain teaser.
All right. How many animals of each kind did Moses take into the ark?
Moses. Wait a minute. Wasn't it Noah who built the ark?
Exactly. It's a trick question.
Ah, you got me.
A lot of people, they just process the question quickly. They think about the story, maybe start picturing the animals.
Yeah, I was already thinking about pairs of animals.
Right. But the key detail is the name. It wasn't Moses, it was Noah.
Yeah, I totally missed that.
The question activates this familiar biblical context, and Moses is a prominent figure in that context, so his name doesn't immediately seem out of place.
Right.
It's like our brains make this quick, unconscious association, even though it's factually incorrect.
So we fill in the blanks based on our expectations.
Yeah, based on our sense of what's normal in that specific scenario.
Interesting. It shows how context can really influence our thinking.
Yeah.
Okay, I'm starting to realize just how easily our brains can be fooled.
Yeah, it's pretty remarkable.
And you mentioned earlier that there are tons of other ways our intuition can mislead us. Do you have time for one more example?
Sure, yeah. Speaking of things feeling right without us knowing why, there were these really interesting experiments involving word associations.
Word association.
Yeah. So people were shown groups of 3 words, and for some of these groups, there was a hidden connecting word that wasn't actually shown.
Like a secret link between the words?
Yeah. For example, dive, light, and rocket, they're all related to the word space.
Oh, I see.
Right. But other groups of 3 words, they had no common association like dream, ball, and book.
Okay, random words.
And participants had to quickly judge whether the 3 words in each set were related in some way.
So they had to guess if there was a connection.
Yeah. And what was fascinating was that people were significantly better at intuitively sensing when the 3 words were actually linked, even though they didn't have enough time to consciously figure out what the connecting word
Like
was.
your subconscious mind was picking up on the connection.
Yeah, it was like their system one was picking up on this subtle feeling of coherence or relatedness.
That's amazing. So even without knowing why, they could sense the connection.
Yeah, and what's even more intriguing is that the mood of the participants actually played a role.
But their mood, really?
Yeah, so people who were in a good mood, they were notably more accurate at this intuitive task.
So happiness helps us think more clearly.
In a way, yeah. While those who were in a bad mood, they perform no better than if they were just guessing randomly.
Wow. So our emotions can really affect our cognitive abilities.
It seems like it.
That's a really interesting connection between our emotions and our intuition.
Yeah, it is. It makes you wonder how our overall state of mind, good mood, bad mood, how it influences all these judgments we make without even realizing it.
Right. Like, are we more susceptible to these biases when we're stressed or tired?
Yeah, exactly.
Yeah,
Something to think about.
it is. Okay, so we've covered a lot of ground here. We've talked about heuristics, priming, cognitive ease, and even the influence of our emotions on our thinking. Is there anything else we should touch on before we wrap up?
Oh yeah, there's so much more to this, but I think one final important concept to highlight is this idea of normality.
Normality.
Yeah.
Yeah.
Our brains are constantly building up this model of what to expect in the world, both consciously, like things we actively anticipate, and unconsciously, the background assumptions that shape our experience.
So it's like our internal model of how the world works.
Exactly. And these expectations, they profoundly influence what we perceive as surprising or unusual.